So the Greeks liked their Earth-centric model, and they tended to ignore things that they didn't want to deal with. And there was more evidence to ignore. And this evidence was important for the next 1,500 years. What they were noticing was that there were wanderers around the universe. They didn't know what they were. They called them planets, meaning the Greek word planetos, to wander. And what was strange about these planets is that they went at different speeds, and some were fast and some were slow. And as they tracked across the sky, they could suddenly reverse for like months. And then they would right themselves and go back again. And they would change brightness and they would change size. And it made no sense at all. They called this reversal motion a retrograde motion. And what you're seeing here is you are seeing Mars come in on its counterclockwise elliptical path, and it is coming toward you now and going along its elliptical path again. This is obviously a time-lapse photo that's probably taken once every few days in this path. So this is Mars. There's a similar retrograde motion for Venus, for Mercury, for Jupiter, for Saturn. And the Greeks knew about this, and they didn't know what to think about it. So they noticed that, like I had said, there's changes. These are moving differently than the stars are moving, and they seem to make chaos out of the sky. Well, about 300 years after Aristotle, a new mathematician goes to Aristotle's academy and learns algebra and geometry there. His name is Ptolemy, and he creates a new model based on Aristotle's model that is still putting the Earth at the center of the universe and assuming that the Earth is motionless. Everything is moving around the Earth. The Earth doesn't move at all. No rotation, no revolution, motionless. He takes this model and recognizes that he's got these wanderers out there, and if he does the math just right and puts the Earth off center a bit in this model, that he can make sense out of all these wanderers by applying gears or epicycles to backpedal these wanderers and time them just right. He can vary their speed, and these epicycles actually do an okay job of predicting the movement of the planets. This is a rendition of his model that lasted 1,400 years. And these are the epicycles that line up between the sun and the Earth. And these gears help to mark that time when everything seems to go backwards and forwards and backwards and forwards. Well, as you can see, this gets really complicated really fast because you have epicycles everywhere. And it gets messy. But this is Ptolemy's model. And It's widely accepted. This is his model that lasts for about 1400 years. If he had the correct model, he would have been able to analyze the data differently. This is a way to look at what's actually happening and come up with a different model. On the right is Ptolemy's model, and it has the Earth at the center and the sun moving around the Earth. And in the red is Mars. And what they noticed was that when the Earth is at the center of the universe, Mars seems to go backwards and then forwards again. And it happens about once a year that this happens. It goes back around. What was actually happening is this. The sun was at the center. And the Earth, just like a skater, when she draws her arms in and makes herself have a smaller orbit, she rotates faster. The Earth is closer to the sun than Mars. It's rotating faster. Watch the Earth. It catches up to Mars and goes past it. In the meantime, Mars looks like it is backtracking. Let's watch it again, okay? The Earth goes faster, catches it. Watch the Earth. Mars seems to be in the back. It's really slowing down. And now the Earth comes around and catches it again. Mars seems to be ahead, and now Mars is behind. So this is due to angular momentum, just like a skater speeds up when she draws her orbit closer to her. Mars seems behind, then Mars seems ahead. This emphasis on mathematics was worldwide, from China to Mexico, and it moved into the Muslim world, especially when Arabs conquered Persia about 800 AD, and then moved into, here you've got Arabia, right? Arabs conquered Persia and moved into India and started bringing back a lot of the knowledge from the courts in India and in Persia, bringing back texts, bringing back priests to teach. And in fact, in conquering Persia, Muslims were able to see Aristotle's old teachings, because at this time, in 800 AD, the Roman Empire had fallen. And in Western Europe, education was falling apart. The old texts from Greece that had been translated and moved to Persia were taken up by the Muslim conquerors and looked at and studied. They were reintroduced to the West, because remember, the Ottoman Empire went all the way to Spain, and by translations, and reintroduced to the West there. The Western interpretation of Aristotle figured into the new religious awakening of the Middle Ages, that heaven was perfect, like Plato had said. The earth was imperfect, and in fact corruptible, like Aristotle said. So the center of the earth, which is farthest away from the heavens, must be hell. And Aristotle's old teachings became part of Christianity's dogma. You can see why. This was all brought back by Islamic conquerors. Those Islamic astronomers actually took Ptolemy's epicycles and added to them. And they did this through about 1100, when they got sick of adding to them. And then they found Aristarchus's model and looked at it and said, this makes sense. And in the 1200s, Islamic monasteries and Islamic thought centers started publishing Aristarchus's work. It's really revolutionary. We'll get back to how that impacted very shortly.